Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we're going to answer a question from one of our subscribers. So he has asked me. In fact, this is a question which is asked from how to set up Kafka in Windows, where I have demoed on how to do a load test using Kafka, using JMeter and Kafka setup. But here he has a question that what is Kafka, and can you please explain it in a bit easy way and it's not clear and it felt like I'm reading some sentence. Okay, I agree with that. So in this video, I'm going to tell you what is Kafka. In first, I'm going to give you an introduction about what is Kafka, and then I'm going to give you some examples on it. I believe this would definitely help you to understand what Kafka and how does Kafka works and what are the advantages of Kafka. So with no further delay, let's go to the video. And this is me, Vasan Shanmugam. I welcome you all to our Little Slaw YouTube channel. Please don't forget to subscribe to our channel if you haven't subscribed yet. And please give a thumbs up if you like this video. And don't forget to share the video with your friends. And do join the channel for more perks and discounts for the upcoming trainings. And yep, let's go to the video. So now we'll see what is Apache Kafka. So Apache Kafka. It's like this event streaming platform because it's designed for handling really large volumes of data. Just let me reiterate it. It's a event streaming platform and it's designed for handling really large volumes of data. And the cool part is it's scalable, it's fault tolerant, and it's highly available. So if you're handling a large volume of data, it should be scalable. That's the very first part because the moment you start to engage more amount of data, it should be scalable, right? And also when you're sending back and forth large amount of data, there should not be any fault. So when I say fault, you're sending like 100, for example, like 100 mbps megabytes of data, and even 1 or 2 bytes of data missing would bring down your system, or it could send a wrong data to the receiver or to the consumer, right? So it should be fault tolerant. And then finally, it should be highly available. Not even a single second of unavailability is acceptable by the customers now. So this is, again, let me reiterate, it's a event streaming platform and it's designed for handling large volumes of data. That's the cool part of it. It can handle large volumes of data, and again, it's scalable. So three things: scalable, fault tolerant, and highly available. So that is a quick introduction about what is Kafka. And it's like it's kind of like this powerful message queue. So we all know what is a queue, where we keep on sending messages, and then in the queue, and then in the other end, some applications will receive it in the first come first serve. But what makes it special is that it lets different systems publish and subscribe to real time streams. So, for example, it's not just one system that is sending the message all the time, it is different systems publish and subscribe to real time streams, right? So, I believe you understand what I'm trying to say. So, it's a perfect for real time data pipelines and for streaming applications. So, just to give a quick recap, so Apache Kafka is a event streaming platform and it's designed for handling, yes, you're right, for handling really large volumes of data. And the cool part is it's scalable, fault tolerant, and highly available. And it's again a powerful message queue. Whereas in other queues, I mean the original traditional queues where only one system sends the message and the other system receives it. But here different systems publish and subscribe to real time streams. So that is the main advantage of using Apache Kafka. So it's very perfect for real time data pipelines and streaming applications. So now we'll move on to see some examples. I'll take you through some very simple examples, very uh, basic examples so that you can understand what is Kafka and how Apache Kafka works. And then I will again take you in the technical terms. So far we saw about what is Apache Kafka and how fault tolerant it is. I mean, like what kind of the feature it has. So now it has actually four components. So Apache Kafka has four major components, I would say, and they are the producers, the consumers, the topics, and Kafka brokers. So firstly, let me give you a scenario. So Kafka is like a big messaging system that helps different apps talk to each other in real time, which is like a kind of a postal service for data. And you just imagine a post office where people drop off their letters into mailboxes, and other people, they come and they pick up those letters whenever they want. So this is like a place where you drop off your message and others. I mean, like when I say drop off message, it's not just you. It's like a group of people. So they can drop off their letters into the mailboxes in the post office, and other people, some other people who can come and they can pick up their letters whenever they want. So that's the breakdown. And here we're going to see the first part of it is the producers. So these is the people who are going to drop their letters. So these are like people who write the letters and drop them in the mailbox, which is here it is Kafka. And these producers, so here you see a set of people which we normally call it as producers. So these people or these apps or these people who send the messages, which could be anything. It can be any message. It can be an order, it can be user action, or it can be an update. So these are the main uh, component, I would say, in terms of Kafka, because these are the people who send the messages. So it can be any message. Because since I'm saying from the beginning, it's not like one particular people or one particular app is going to send. It's just multiple people or multiple applications is going to send. So any application can send their own set of messages. So it can be an order message, it can be user action, or it can be an update. So that's the first part. So far we saw about the producers, right? And the next thing is we're going to see about the consumers, the second component of the Kafka. So the second and the important component of Kafka next to the producers is the consumer. So what does a consumer does? So consumer is again a set of people like what we see for producers. Like we have a set of people who are in producers who writes the letters and drops them in the mailbox, and then they sends the messages. On the other hand, these consumers, so these are the people who checks the mailbox. So they check the mailbox every now and then, and these consumers take the messages from the Kafka. So Kafka is the post box in our scenario. In this example, it's just the post box, and then they take their letters from there and then they use them. So it can be anything. It can be like displaying any notifications or updating a system or processing orders. So these are the consumers who consume the messages, like the way they have called. So these producers are those who sends the letters, and these are the consumers who just checks the mailbox for new letters and then they use them. So that's the uh, job, or that's the duty of these consumers. So they don't write back to the producers. They just uh, reads the message. They just take the messages from the Kafka and then they just use them. So same way, but the producers, they write the letters and then they send it to the consumers, and the consumers just use them. They take it from where do they take it from? So they take it from the place where the producers have posted it. So they take it from the post or from the Kafka and then they use them, right? So now we'll move on to the next topic, which is the topics. So the third component, which is the topics. So these are like separate mailboxes for different types of messages. For example, one topic could be for user activity and another for system logs. So when I say topics, these are distributed, like they are like separate mailboxes. They are not like one single mailbox. They are like multiple mailboxes, and each mailboxes has its own type of message. Because when you use a same mailbox or a same queue for different types of messages, it could lead to mess up. So that's the reason every single type of message has its own separate mailboxes. For example, one topic could be for user activity. So in this scenario, one topic, I'm using this mailbox for user activity, and I'm using the second the other mailbox, I'm using that for system log. So it can be like any number of mailboxes for any type of message. So if you have like 100 different types of messages, you'll have 100 different types of mailboxes. So that is how the user activity or the topics work. So initially you had we saw about the producers, and then we saw about the consumers, and then we are seeing about the topics, where there will be like separate mailboxes for different types of messages, which is in other words, I would say every single type of message will have every separate mailbox. And then the last topic, which is the Kafka brokers. So we saw about three components initially, which is the producers, the consumers, and the topics. And now the last part of the last component, which is the Kafka brokers. So this is like the post office. So the Kafka brokers is like a post office which store all the mails, or I would say all the messages, and make sure it gets to the right people. So this is a kind of a post office where they sort the message and then they send it to the right people. So that is what the Kafka brokers does. So far we saw about four different components. One is the producers who writes the letters and drops them in the mailbox. Um, Let me just go to the initial one. So we have the producers. So these are the people who writes the letters, drops them in the mailbox, and the producer sends the messages, which could be anything like orders, user actions, or updates. And then we have the consumers who check the mailbox for new letters. Consumers take the message from the Kafka and use them. And then we have the topics. So these topics, we saw that they have separate mailboxes for different types of messages. It can be user activity or it can be system logs. And then finally we have the Kafka broker. So this is like a post office. So what does a post office does? They sorts the message. So they stores all the mails and then they sorts it and then they sorts them and then they make sure it gets to the right people. So that is the main or the major four components which Apache Kafka has. And this is just a basic example. So I believe I would have explained you in a very basic manner. So you understand what is a producer, what is a consumer, what is a topic, and what is a Kafka broker. And now I'll take you to the technical part. Before that, Kafka is really fast and it can handle huge number of messages, which is why it's often used by big companies to manage data flowing between apps in real time, like streaming data or tracking activity. So now we'll move on to the technical part, like how does the technical part of Kafka works. So far I gave you a very basic example, and now I'll explain you in a technical term. So what is Kafka? So Apache Kafka is a distributed event streaming platform which is used for building real-time data pipelines and streaming applications, and it's designed to handle large volumes of data in a scalable, fault tolerant, and highly available manner. I have explained you in the very beginning. So they handle large amount of data, yes, and they are scalable, and they have to be fault tolerant, and they should be highly available. And then they are excel at allowing multiple systems to publish and subscribe to real-time streams of records. So moving to the first part, which is the producers. So yeah, so let me come back to the first section of first component, which is the producers. So these producers are the entities that publish or they send the records to Kafka topics. So topics actually is quite important in terms of the Kafka. So I'll explain you before moving to the consumers. As a second component, I'll explain you about topics so that it will be easy for you to understand. So these producers, okay, so these are the entities, they publish or they send the records or they send the messages to Kafka topics. So not anywhere. So they send it to the Kafka topics, which I have explained to you like the mailbox. So just imagine your mailbox is going to be your Kafka topics. So a producer can decide which topic to publish to, and also he can assign the messages to specific partitions within the topic. So he has the complete access, that he has the complete deciding authority to which topic he has to publish to, and he also can assign the messages to specific partitions. So it's not just the topic, it's not just he can assign the messages to specific topic, but also he can assign the messages to specific partitions within the topics. And that's the highlight of using the producers in terms of Kafka. And then like I told you, I'll explain you the topics before I move to consumers, because once I explained you the topics, it will be easy for you to correlate it with the producers and consumers. So coming to the topic, so topics is a so it's just a very common word. Like topic, it can be category or it can be a field name to which the records are sent by producers. So I have told you in the very first, the beginning, about the producers, right? So these are the categories, or these are the feed names that to which the records are sent by producers. So the producers will send the data. So topics are partitioned, so they can be partitioned, and also the highlight of this is they can be partitioned, they can be highlighted across multiple Kafka brokers to ensure scalability and fault tolerance. So since we were talking about this two aspects or two features, which is scalability and fault tolerance, so to make them available and to make them fault tolerance, these topics are partitioned, so they can be partitioned also. They get replicated. So when I say replicated, they'll be like in multiple numbers, the same record, but it will be in multiple copies. So that's what we call as replication. And then in the very first one, I have told you that the producers have the deciding authority to send their message to any partition of the Kafka. Right. So what is a partition? So a topic can be split into multiple partitions. So here I have a box, which is one particular topic, and just imagine you have multiple partitions inside this box. So that is what the partition is like. You have multiple split inside this. So each partition is an ordered sequence of records, and each record in the partition is assigned to unique offset. So that is what the partition is. So let me just quickly reiterate. So a topic can be split into multiple partitions. So just imagine this is a topic, this is a box where you can split into multiple partitions, and each partition is an ordered sequence of records. So you have a partition, and this partition is a ordered sequence of records. So you have a set of records in a sequence. So like just imagine like you are standing in a queue. You're going to a theater, you're trying to book a ticket, and you have like five different queues. So five different queues is five different topics, but the five different topics are booking a ticket for one particular cinema, but still you have partitions like one for the female uh, viewers, and one for the male, and one for the child. So just imagine that way, right? So each partition is an ordered sequence of records, so they'll be in a ordered sequence. The first person who stands in the queue gets the ticket. So same way, the Kafka topic has multiple partitions in it, and each are like unique. So they are like unique. And then the replication. So when I say replication, for the durability, Kafka replicates the partition across multiple brokers. So if one broker goes down, the data is still available on another broker. So that is why. So yeah, this is very basic. I mean, why do we do the replication, or why do we do copies? It's because for increasing the durability, because Kafka replicates the partitions across multiple brokers. So if one broker goes down, so when I say brokers, I have explained you before, it's like a post office. So when one post office is shut down, just imagine the post office in one place is shut down, but you have that particular message in another post office. So if I'm trying to reach post office A and it's closed, it's down, I can get the same message in post office B. That's it. The problem is solved. So the partition is also working fine. The replication is also working fine. That's the main ingredient, or main component of, or main feature of the topic is. And then moving to the second part now. So now you will understand how the consumer works, right? So you send a message, the producer sends a message, and that message is split into multiple partitions inside the topic. And just imagine he sends a message and it's been replicated to different post offices. He sends a message to the Kafka, and it replicates to different post offices. So the producer do not need to worry about that, whether that message is going to fail or whether that message nobody is going to read it. So that's how the um, topics works, or the Kafka works. And then this part here, the consumers, right? So when it comes to consumers, I have already explained you. So the consumers are those or the applications or systems that subscribe to topics. So when I say topics, we have seen just now. So a topic is a category or a feed name. So they subscribe to those topics and they read the records which are produced to those topics. So the producers sends the message to the topics, and these consumers get those messages. They read the records produced to those topics, because Kafka consumers are responsible for just processing the message. They don't do anything. They just process the message. Okay. So each consumer belongs to a consumer group. So you can see a set of consumers. So consumers belong to a consumer group, and there will be like different set of consumers, and they all belong to different set of consumer groups. And Kafka guarantees that each partition is consumed by only one consumer within a group for parallel processing. So that's another highlight of how the Kafka, the consumers, works. And then coming back to this part here, so where we were seeing about the topic. So we were seeing about this particular topic. So and then we have discussed about the partition. So Kafka topics are divided into partitions to allow parallelism and scaling. So a partition is a sequence of records, which I have told you very just now, where each record has a unique offset, and records in partition are immutable. So when I say immutable, it cannot be changed. So when it is mutated or mutable, it is changed, but when it is immutable, it cannot be changed. It will not change at any point of time until it reaches the consumers. And Kafka ensures records are read in the order they were written within each partition. So it's just like a person who is sitting at the counter and issuing the ticket. So the first you come, the first you'll get the ticket and you'll go back. So that's how the Kafka records work. So they are written in an order that it comes in the first order, first come, first serve, and they're immutable. And then the Kafka broker. So the fourth topic, so the post office guy. So the Kafka broker is a server that runs Kafka, because this Kafka broker receives record from the producers, from the very first set of people. So Kafka brokers gets the message from the producers, and then what they do? So they store them in the post office. So they store them on the disk and serve it to the consumers, to the second set of people, to the consumers when they fetch the record. So these consumers wait, or they take whenever they are available from the broker or from the post office. So the Kafka cluster consists of multiple brokers to ensure high availability and horizontal scalability, and each broker is responsible for handling a subset of partitions. And then we have other components as well, which is the Zookeeper. So Zookeeper is used by Kafka to manage cluster metadata and coordinate the brokers. So we have several brokers, right? So these brokers will be coordinated by the Zookeepers, because Zookeepers help with broker leadership election, partition assignment, and maintaining the configuration of brokers and topics. So we have the last two components. So these two components are managed and they are maintained by the zookeepers. But in new versions, so that's the reason I'm keeping it at very last. Kafka is moving towards eliminating the zookeeper in favor of its own internal care aft model. So zookeeper is going to be outside. It's going to get away from the Kafka. So that's the reason I'm keeping it outside the component part. And these are the major components in terms of the Kafka. So let me just give you a quick review on how Kafka works. So producers sends a message to a topic. So let me show you. So these producers, they send a topic, and these messages are stored in topics partitions. And then the next part, which is the consumers. So these consumers subscribe to the topic and read the message from partitions, and Kafka ensures the messages within a partition are read in order and they were produced. And then each consumer and a consumer group reads from different partitions, which enables parallel processing. And then we have the Kafka brokers. Yeah, so these are the Kafka brokers. So they store the messages on the disk and replicates the partition across multiple brokers to ensure reliability. And yeah, like I told you, the advantages, yeah, the scalability, the fault tolerance, the high availability, and the performance. So these are the advantages. I don't want to again give you a complete understanding of that. We all know what is scalability and what is fault tolerance and what is durability and what is performance. So yeah, overall Kafka is widely used in real-time analytics, log aggregation, stream processing, event sourcing, and building scaling data pipelines. So with that, I come to an end, and I definitely believe this video would be very useful. And again, I would like to thank you for asking this question. Thank you so much. This question can help you even in interviews as well. So please do watch the entire video, and thank you again for watching the video till the end. Until I meet you in our next video, it's bye bye from Asan Shanmugam and your favorite Little Star YouTube channel. Take care and bye bye.